Now, look at the first one here. This is for lesson 1. Okay, here in this lesson, we learned how can we find the limit by or from the graph. Look at the function g here. This function g is graphed in this figure here. Now, find limit f of x when x approaches 0. Now, here I wrote the final answer, so please don't look at them. Stay with me, please. Here now, I have, yes?
تيجي انت هتحطيها على الكورس ماتيريالز؟
Yes.
اوكي.
So here now I want to find limit f of x when x approaches 0. Look at point 0 here. Sorry, here, for this point 0. For this one here, if you look at 0 from the right, okay, limit, so here it will be limit f of x when x approaches 0 from the right. And see here, when x approaches 0 from the right, what is the value of the limit?
2.
No, look here. They are close to be 0. Look at 0. The values are close to be what? Are going to be near near 0. And limit f of x when x now approaches 0 from the left. Look at the 0 from the left here. The limit approaches to be what?
0.
0 also. Now, since now the limits, or since they are two-sided limit, okay, and these two-sided limits exist and have the same value, so I will say that limit f of x when x approaches 0 is equal to 0. Is it clear?
Yes.
Now, let's do B now. In B here, I want to find limit f of x, but when x approaches -1. Look at -1 here. Here I have -1. Okay? I want now, because limit or -1 are two-sided limits, I need to find -1 from the right and -1 from the left. So, I have to find now limit f of x when x approaches -1 from the right, and then also limit f of x when x approaches -1, but now from the left. Now, -1 from the right. Here is -1. From the right, it approaches to be what?
2.
To be 2. And from the oh no, so let's put the opposite. Okay, and from the left, it will be also
2.
It will be also 2. Is it clear? How can I find the limit?
Yes, miss. Yes.
Okay, so because they are equal, I can say that the limit f of x when x approaches -1. So because of that, I can say that limit f of x when x approaches -1 is equal to 2. Now, let's find C. When x approaches 1, where number 1? Here is number 1. I want now limit f of x when x approaches 1, but now from the right. The value approaches to be what?
2.
2. So limit f of x when x approaches 1, from the right, one from the right is equal to, and limit f of x when x approaches 1 from the left. Now look at 1 from the left. What about the values? They go to be near what? To be 2 also. So is the limit exist now?
Yes.
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 So I can say that limit f of x when x approaches 1 is equal to 2.
ماس
Yes.
هلا انت لو جبتي لنا انه هيك زي هيك سؤال بدون انه تحكي لنا انه من اللفت ولا من الرايت، احنا بدنا نطلع اللفت والرايت يعني.
Yes. Now let's find. Yes.
مسموح نستعمل كالكوليتر صح؟
Yes. You can use it. Now f of 3. Okay. For f of 3 here, where is 3? Here is 3. I want to find the value of the function at point 3. I will look at the open or the closed circle.
The closed.
The closed. The closed. Thank you. So the closed circle is at point what?
2.
2. So the f of 3 now is 2. Now what about f of -1? I look also at the closed circle. What about f of -1?
1.
1 up.
It is 1 also. Thank you. Okay.
Teacher, if we don't have a closed circle, what should we do?
It's not undefined.
Okay.
Now, limit
Teacher,
Yes.
Miss, I have a question.
Yes. You can ask. Yes.
Now, always when x approaches to 0, the answer is 0.
No, according to the graph.
Okay.
Okay. Now, limit f of x when x approaches 2. Look here, where is point 2? Here is point 2. Okay, now look at limit f of x when x approaches now 2 from the right. Look at 2 from the right. Here, the value approaches to be what? 3. Thank you. Thank you, 3. And limit f of x when x approaches 2 from the left now. Look at 2 from the left. It's 2. Thank you. Now, is the limit exist? Or does the limit exist?
No.
No.
No, it doesn't exist. So I can say that the limit here of f of x when x approaches 2 does not.
Teacher,
Yes, Nihal.
why we cannot say that limit f of x when x approaches to 2 from the right equals to 2?
Look at here. Look here. Here we have 2. Where is 2 from the right? Look at the purple line that I draw it. Look at the right. Here. Look at the right from here. Okay. Where is the line? Look at the line. The line that touches the asymptotic line. I mean, you have at point 2 make an line like asymptotic line. Okay, or a vertical line. Now, at this vertical line, look at the graph that's touched from the right. As I draw here, look here, I make a line then I will look at the right. Look at the right here. Where the curve, this curve, or this line, according to the question. Okay? For this curve, where is that it's touched the line? My purple line. Where is touched?
3.
Sorry. Here is my line. Here is my curve or my line or my point according to the question. Look at this here. Where it's touched my line? At point 3. So I can say that for 2 from the right is equal to 3. But what about the left? I will go back to my curve now and I will look at the left. Which line is touching my purple line from the left? This one. Is there anyone else? Just only one, which is at point 2.
Yes.
So I can say that from 2 from the left is 2. Okay. Now, here now, for the function f graphed in the figure here, find limit f of x when x approaches -2. Now, Darine is here, is it right? Where's Darine?
Yes, teacher.
Yes, Darine. Did you remember yesterday when you asked me about if for the that's if you have like this as an example at point 3, and you asked me that is there a value for the function because it's closed here. You told me it's closed or open. Now, if it's closed, okay, and also my explanation here for all the girls. If it's closed like this at point 3, that's mean there's a value of the function. And there's the value for f of 3. But here, if you look at point -2, it's open. What does it mean? That means that there's no value for f of -2.
The function.
So
there is a value for the limit.
Yes, there's a value for the limit, but there's no value of the function. That's Neo, as you see here. Is there a hole at point -2?
Yes.
Yes, that's mean a hole. That's mean my graph is not continuous. Is not continuous. That's mean it is discontinuous. So that I will go to my lesson number 5 that we talked about yesterday. This lesson here, because the limit is existed, but the function is not defined. So I can say the limit is not continuous because here we have a hole. So the graph is not continuous. So if I want to make it continuous, I need to make this point here a closed one. Is it clear?
Yes.
So if I want now to make it closed one, I just put a closed circle here. So I can say there's a value of f of -2, which is equal to 0. And the limit also exists, which is equal to 0. And since now the limit is equal to the value of the function, I can say the function is continuous at point -2. But if I remove this red circle from here, if I put it as an example here, look now, the function now at point -2 is opened, so that there is a limit, but there's no, and also there's a value of f of -2, which is equal 1, but it's not continuous.
Teacher, can you say again when it will be continuous?
Now, in the previous lesson, we said that if the function is defined, if the function has a value, like here, at point 2, the function is 0. The value of f of 2 is 0. And then I have to find the limit. So the first step, I find the function. The second step, I find the limit. Okay, now for this limit here, as you see, the limit from the left and from the right, after you find it, it will be 0. Okay, and here for the function, is it open? What does it mean? Without the red circle. Okay, don't look at the red circle. Here, there's a value of the function, but the function itself, the value of -2, there's a value of the limit, but the function at point -2 is not defined. So I can say this function is not continuous because it has an hole at point -2. If you have this red one here now, that means this is a value of -2. Here, it will be f of -2. F of -2 is equal to -1, but it's not equal to the value of the limit. So it's also it will be not continuous. It will be only continuous if this circle here is closed, my open one, and my graph will be continuous. So I can say that it's continuous, it's mean like this, without any hole. I can say that my graph is continuous. Now back to our revision. Now let's look here. The value or the limit of f of x when x approaches -2 is equal what? Look at the -2 from the right, -2 from the left. It approaches to be what?
0.
Be 0. So I can say now the limit is equal to 0. Now look at point 2. At point 2 here. Look at limit f of x when x approaches 2 from the right now. 2 from the right. I will draw my red circle. Now which curve or which point touch my red line from the right? This line only. It's touched from point 1. So I can say limit f of x at x approaches 2 from the right is equal 1. And limit f of x when x approaches 2 from the left, from here, it's -1. So I will say that the function does not exist. Now, I want you now to find the values of a where the limit f of x when x approaches a is equal to 0. Yes.
2 and -2.
Limit f of x when x approaches a is equal to 0. Who tell me?
2, yes, teacher.
2, no, 2, how to? 2, this is for f of 2, -2, thank you. At point -2, the limit is 0. Now, find the values of a where the limit does not exist.
2.
At 2, thank you. Now, look at this one here, then this one it will be uploaded on the course material. I have to go to the next worksheet because there's no time. Let's solve this one now. For the function g, here, limit f of x when x approaches 0 from the right. Here is 0, but now from the right, it's bound. It's increase or decrease without bound?
It's increase.
Increase. So I will say that 0 from the right is positive infinity. Now look at 0 from the left. It's decrease without bound. Is it right?
Yes.
Yes. So I will say that it's negative infinity. Now, here also you have the same ideas. Okay, and there's an answer for them. You try to solve it by yourself and ask me if there's no question. If you have any questions, sorry. Now let's go to the worksheet number 2. In this worksheet here now, I have to compute the limits without looking at the graph using the equation. Limit is here now. Given that limit f of x equal to and limit g of x is equal -4 and limit h of x is equal to 0. I want you to find now b. Limit h of x minus 3g of x plus 1 when x approaches a. As we said, we can distribute the limit. So it can be written as limit h of x when x approaches a minus 3 limit g of x when x approaches a plus 1. I just distribute the limit on the functions. Then after that, limit h of x is the value of it. It is given 0 minus 3. Limit g of x is -4 plus 1. Now -3 times -4 is 12 plus 1, 30. So the answer here is 30. Is it clear?
No, Miss, may you repeat it?
Yes.
Yes.
Limit h of x when x approaches a is 0. So I just put the value of 0 here. Okay, then 3 limit g of x when x approaches a. Where's limit g of x? It's -4, it's given. So what I have to do now, I just bring the value of limit g of x and I evaluate it here, which is -4. The -3 times -4 is 12 plus 130.
Okay.
Now, let's do limit g of x squared. Here now. This one, what does it mean? That means I can write it like this. Limit g of x squared. So, what is the value of limit g of x? -4. Thank you. It's -4. So, I will say now -4 squared, which equal to 16. This is now the value of the function. Now for E. Here now, I want to find limit the cube root of 6 plus f of x. What can I do here? I can say limit 6 plus f of x raised to the power 1/3. Then I will add now six. What is the value of f of x? It's 2. So I will say because of that, so because of that, I can say now it's limit 6 plus, what is the limit of f of x? Is 2. So the answer will be 8 raised to the power 1 over 3. Or can I rewrite it as the cubic root of 8? What is the cubic root of 8?
2.
2. So the answer here is 2. One minute, please. I will. يلا تعالوا. Now look at question number 2 here. Find the limit. Now, if you look at number 1, is this a rational function or a polynomial function? Polynomial. So what does it mean? That means it's very easy for me. I just evaluate 3 into x. Okay? If I have a polynomial, it will be very easy for me. What I have to do now, I will say its limit, or limit. I will say that it's 3 cubed minus 3 times 3 squared plus 9 times 3. 3 cubed, which is 27, minus 3 times 29, which is 27 also, plus 27. So the answer will be 27. So if I have a polynomial, it's just so easy. Just evaluate the value of x. Now, go to the second one now. For the second one here, what did you see? Is it a polynomial or rational?
Rational.
It's rational. So what I have to do now, because it's rational, I have to go to the denominator. Okay, look at the denominator here. What is the zeros of the denominator?
1.
Negative 1. Now, so the 0 here is negative 1. Now, after I found the 0, look at where's the value of x, where's the value of the x, where's the limit is approaches to. It's what? It's a 3. Since now the 3 is not as the same as negative 1, so I will repeat, I will find the denominator, the zeros of the denominator. I will look at where's the value of the limit is approaches to, which is approaches to 3. Is the 3 as the same as negative 1? No, it's not equal. So I have to what? To evaluate the value and deal with it as a polynomial function. I can say now it is negative 1 squared minus 2 times negative 1 over, sorry, not negative 1, 3. Three squared minus 2 times 3 over 3 plus 1. And you will find the answer. Is it clear here? Look at the zeros of the function. Because it's not as the same as where the limit approaches to, I just evaluate. Now look at number 3 here now. At number 3, look at it. Is it a rational or a polynomial?
Rational.
Yes. So because it's a rational, I have to find the zeros of the denominator. Let's find it. Yeah, I will give you 1 minute.
It is negative 6.
Now, so here we have a rational. We have to find the zeros of the function. The zeros here now, it will be x plus 3 times x minus 2. I just factorize the function here. Now, look at the zeros of the denominator. What is the zeros of the denominator here? It is negative 3 and 2.
-3 and 2.
Okay, so look at now at the limit here. What is the value of x that approaches to it? It is 2. And since 2 here is the same as 2 here, what I have to do? I have to simplify. So I have to simplify now. I will go back now to the denominator and factorize them. The first one, it's x minus 2 times x minus 2 over x plus 3 times x minus 2. Then after that, I will simplify them. I have now x minus 2 over x plus 3. So my new limit will be limit x minus 2 over x plus 3 when x approaches 2. Then I will put here now 2 minus 2 is 0 over 2 plus 3 is 5. The answer will be 0.
بس
Yes.
ما فينا لو من الأول عملنا simplify للx اللي هي 2.
Yes, but you have to check. But you have to
يعني
check.
مثلا أنا لو عملتها بدون ما أعمل تشيك تطلع علي غلط.
How did you know that if you have to simplify or no?
أنا حطيت ال 2 مكان الإكس طلعت معي 0.
Oh yes, okay. Just to try, يعني. Okay. You can also evaluate 2 in the function. If it's give you 0, so I have to simplify.
Okay.
Now, let's check what we have to solve also.
Teacher,
Yes.
the answer is 0 after we simplify it.
Yes.
It will not be again undefined because the answer is
No,
0.
if it is 0 over 0, it's undefined. If it is a number over 0, it is undefined. And that's mean and that's made I made a problem. But if it is 0 over number, it will be 0.
Okay, too.
Now, look at this one here. X plus 7 over x squared minus 49. For this one here, limit. Now look at x squared minus 49. What does it mean? That's mean this is an x minus 7 and x plus 7. I can factorize it as x minus 7 and x plus 7. So it is x plus 7 over x minus 7 and x plus 7. Who's talking?
تيتشر هو في جريد دخل علينا دلوقتي بس مش عارفة مين.
Grade 8, grade 8, please, not now. After 2 minutes. So now here. So by now, I have an x plus 7
Hi,
over
teacher.
x minus 7 over plus x plus 7. Then after that, I will simplify them. I have only limit 1 over x minus 7 when x approaches 7 from the right. Now, if you have this function, you have to check